Good afternoon, everyone. My name is Idogwu Chinonso, and I'm a student here at web3bridge cohort 8. Here at web3bridge cohort 8, we are being trained to become smart contract developers. And as part of the requirements for this program, we are expected to submit a video every week detailing our progress so far and what we've learned during the course of that week. And yes, you may have guessed right. This is my first video, and I'm sure you'll be seeing more videos like this in the next coming 16 weeks. This week, we are reintroduced to the blockchain. I use the term reintroduced because a lot of the concepts or terms we were taught this week were terms which most of us felt we knew or understood them. But actually, level of understanding then were based on the terms, and we needed to work on what we knew or what we felt we knew before we could move forward to build on the concept we've crafted so far. We learned what a blockchain is. We were taught about the Ethereum blockchain, smart contracts, components of a blockchain, mining, consensus mechanisms, the different types of consensus mechanisms, the role of miners and consensus. We were taught about clients, accounts, wallets, and their different types. We also learned what a block was, the components of a block. We were also introduced to the concept of gas. We learned how transactions were executed in both the proof of work and also the proof of stake consensus mechanism. In order to connect these terms together, I would say a blockchain is a global, decentralized connection of computers in a peer-to-peer network, whereby data is maintained, transmitted, and stored across all the computers of the network. And in the concept of blockchain, those interconnected computers are termed nodes. We, as users of the blockchain, we create transactions in the concept or in the term of we create requests and we send those requests to a particular node. Then that node verifies the request we make. In terms of like transaction, it verifies that okay, we have the actual amount we want to transfer to another user, or the data we are sending is actually authentic. Then it propagates that request, or it distributes that, it sends that request to the other nodes or the other computers in that network. These transactions that were sent or propagated to the network by the individual node is stored in the mempool of other nodes in the network. According to the Ethereum proof of stake consensus mechanism, every 12 seconds, a particular node in the network is selected randomly to become the block proposer for that block for that 12 seconds. What the block proposer does is it picks transactions, a group of transactions from the mempool, after which it aggregates them in a form of like an execution payload. It runs those transactions or it executes those transactions, then propagates them as a block to the other networks, to the other members of the network, that's the nodes of that network. The other nodes of the network this time around, what they do is just to verify those transactions. Since the block has already been proposed, it makes the job easier for them to just re-verify the authenticity of that block to confirm that everything proposed by the block proposer is proper and it's what it should have been. And in condition or situations where the block that was proposed is not as it should have been, then the Ethereum will take consensus mechanism has some incentives or some actions in which he has put in place to punish those blocks by either slashing or removing their stake totally from the pool. That block that was actually proposed by the block proposer becomes a valid block, and it gets added to the chain if 66% of the other nodes in the network attest to the fact that that block is a valid block. So if 60% of the entire nodes in the network verify that that block is correct and authentic, the block becomes a block which contains a list of transactions or requests executed within those 12 seconds. They get added to the blockchain network itself properly. This sequence of actions usually occur in the proof of stake consensus mechanism. The proof of work consensus mechanism has its own different sets or different sequence of actions in order to reach a consensus on the current state or the current block to be proposed. And currently now, Ethereum is on the proof of stake consensus mechanism. It's migrated from the proof of work to the proof of stake consensus mechanism for different reasons, and I think one of the major reasons is the energy consumption requirements for proof of work consensus mechanism, since it's needed the individual nodes to actually compete within themselves for the first person to propose the block, which becomes valid. And but under the proof of stake, the network itself chooses a one node at random. So this time around, it's reducing the energy consumption which is required by the other nodes to verify or to propose. What I just explained now, it's how transactions are run on the Ethereum proof of stake consensus mechanism. Yeah, and I might not have been able to touch everything we taught this week in terms of like concepts like gas, concepts like wallets, and some other stuff. But I might be able to do that in subsequent videos. I might not. But I'm sure with this short video, probably long video, that you understand what the blockchain is and how your transaction actually operates now on the Ethereum blockchain network using the proof of stake consensus mechanism. Thank you very much for watching this video. I hope you look forward to new videos that will be coming within the next few days and more coming every week, like one video every week or probably two, who knows. But thank you very much for watching, and if you're interested in watching subsequent videos, you can follow me on social media. You can also subscribe to this YouTube channel and more for more videos coming. Thank you very much.